Hello everyone, in this video we're going to solve 2025 AB Precalculus free response question 2. A musician released a new song on a streaming service. A streaming service is an online entertainment source that allows users to play music on their computers and mobile devices. Several months later, the musicians began using an app at time t=0 that counts the total number of plays for the song since its release. A play is a single stream of the song on the streaming service. The table gives the total number of plays in thousands for selected times 2 months after the musicians began using the app. At time t=0, the total number of plays was 25,000. At t=2, the total number of plays was 30,000. At t=4, the total number of plays was 34,000. So this table right here. The total number of plays in thousands for the song since its release can be modeled by the function d given by d of t equals at squared plus bt plus c, where d of t is the total number of plays in thousands for the song since its release, and t is the number of months after the musician began using the app. Question AI. Use the given data to write 3 equations that can be used to find the values for the constant a, b, c in the expression for d of t. Find the values for a, b, c as decimal approximation. Alright, so we're going to use 3 points right here. So a, I. Alright, so we have the first equation, t=0, so we have a times 0 square plus b times 0 plus c equals 25, right? Second equation, a times 2 square plus b times 2 plus c equals 30. The third equation, a times 4 square plus b times 4 plus c equals 34, right? Now I'm going to simplify this one. The first one, c equals 25. Second one, you have 4a plus 2b plus c equals 30, right? The third one, 16a plus 4b plus c equals 34, right? Now question 2i. We need to solve for a, b, and c, right? So we substitute 25 for c into 2 equations right here, right? So we have 4a plus 2b plus 25 equals 30, and 16a plus 4b plus 25 equals 34, right? Now I'm going to subtract 25 both sides, so it could be 4a plus 2b equals 5, and 16a plus 4b equals 9, right? Now for the first equation right here, I'm going to multiply both sides by 2. So I have 8a plus 4b equals 10. I rewrite the second equation, 16a plus 4b equals 9. Now I'm going to subtract these two equations vertically, so I have negative 8a equals 1, right? So a equals negative 1 over 8, right? Now I substitute negative 1 over 8 for a into the first equation right here to solve for b, right? So I have 8 times negative 1 over 8 plus 4b equals 10. So I have 4b equals, this one equals negative 1, right? Add negative 1 both sides. So it could be 11. So b equals 11 over 4, right? So finally you have a equals negative 1 over 8, b equals 11 over 4, and c equals 25, right? Now since the question wants us to leave the answer as decimal approximation, so a must be negative 0.11 125, right? B equals 2.75, right? And C equals 25, right? So D of T equals negative 0.125 T squared plus 2.75 T plus 25, right? Alright, question B, I. Now, use the given data to find the average rate of change of the total number of plays for the song in thousand per month from t equals 0 to t equals 4, right? So t equals 0 is going to be 25, t equals 4 is going to be 34, right? So you have the average rate of change is going to be d4 subtract d0 over 4 subtract 0, right? So d4 is going to be 34, subtract d0 is going to be 25 over 4. So it could be 9 over 4, right? So 9 over 4 equals 2.25 thousand plays per month. Okay, question 2I. Use the average rate of change found in part BI to estimate the total number of plays for the song in thousand for t equals 1.5 months. So you have the point slope form formula y equals m times s minus s1 plus y1, right? Now we're going to pick the point. I'm going to pick the point s1, y1 equals 0 and 25, right? Look at the table right here. This one, right? Now, m, which means the average rate of change right here, 2.25, right? Now, we substitute over here, so we have y equals 2.25 times s minus s1, which means 0, plus y1, which means 25, right? So I simplify this one, y equals 2.25 s plus 25, right? Now I need to evaluate y of 1.5. It's going to be 2.25 times 1.5 plus 25, right? So I print up the calculator. So I have 2.25 times 1.5 plus 25. Hit enter. The answer is 28.375, right? Now question 3i. Let a t represent the estimate of the total number of plays for the song in thousand using the average rate of change found in part BI. Now for A 1.5 found in part B 2I, it can be shown that A 1.5 less than D 1.5. Explain why in general A t less than D t for all t where t between 0 and 4. Your explanation should include a reference to the graph of D and its relationship to A of t, right? This one right here is A of 1.5, right? And this one is the function A of t, right? The function d of t is going to be, now we need to calculate d of 1.5, right? So it's going to be negative 0.125 times 1.5 square plus 2.75 times 1.5 plus 25. Alright, so we can print up the calculator. It's going to be 2.75 times 1.5 plus 25. Hit enter. The answer is 28.843 thousand play. Right. Now we're gonna wrap this one right here, and the function d of t right here on the same x and y coordinate plane to see how it looks like, right? So it's gonna be like this. Look, within the interval from 0 to 4, right? This one is 0 and this one is like 4 right here, right? And you see that the function d of t is above the function a of t, right? So which means a of t is always less than d of t, right? Now let's move on to question C. The quadratic function model D has exactly one absolute minimum or one absolute maximum. That minimum or maximum can be used to determine a domain restriction for D. Based on the concept of the problem, explain how that minimum or maximum can be used to determine a boundary for the domain of D. Alright, so we look at the graph right here. We see that the quadratic function is concave down, so the maximum should be right here. Right? It's at 11 right here. Right? So you need to say that the quadratic function d of t has exactly one absolute maximum. Since a less than 0, right? A equal negative 0.125 right here. To determine a domain restriction, we need to find the vertex. So the vertex is right here. S equals 11, y equals 40.125, right? Since the song road is unlikely to continue indefinitely, a realistic domain restriction could be 0 to 11, right? From here to here, reflecting the time until the maximum place are reached. Alright, so here's the answer for question C. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand